Laws of logarithms, example 1. Use the laws of logarithms to write the following as a single logarithm or as an integer. Okay. Part A. Logarithm of 5 plus logarithm of 3. Now, since the base here is omitted, we can suppose safely that the base is 10. So these are decimal logarithms. So this is the logarithm in base 10 of 5 plus logarithm in base 10 of 3. Now, since this is the sum of the logarithms, I can use the rule, the law, that says that the logarithm in base a of x plus the logarithm in base a of y equals the logarithm in base a of x times y, like this. So in our case, it should be the logarithm in base 10, so I don't have to write the base, of 5 times 3, which is logarithm in base 10 of 15. So this should be the answer to this first part. In part B, we have logarithm in base 3 of 24 minus logarithm in base 3 of 8 equals. Now, in this scenario, it's best to use the law, the logarithm of a in base a of x minus the logarithm in base a of y equals logarithm in base a of x over y. And the reason for this is that we have the difference in two logarithms. We have subtraction here, so this is the best that we can get from those three laws of logarithms that we have. So applying this, well, I can use the brackets here. Applying this, I obtain logarithm in base 3 of 24 over 8. Okay, and since 24 is 3 times 8, then it says that it's the logarithm in base 3 of 3. Okay, now there is a very interesting question. What is the logarithm in base 3 of 3? And now, according to the definition of the logarithm, this should be the exponent to which 3 has to be raised in order to get 3. So 3 to what? To what equals 3? And you can easily see that it's 3 to 1. Okay, 3 to the first power is always 3. So therefore, the answer to this is just it's 1. Okay, so whenever we can generalize this, whenever we have the situation in which we have to find the logarithm in base a of the number a itself, it's always 1, because a to the power of 1 equals a. This will be very useful, and perhaps it's best if you write down this formula into your notebook and highlight it using some colors or something. Okay, now let's move on to the last part, part C. In part C, we have logarithm in base 2 of 5 minus 1. So this logarithm, this expression here, since there is no brackets, the pair of brackets used, should be understood as follows. First, evaluate the logarithm in base 2 of 5 and then subtract 1. Okay, so we need somehow to use the logarithmic laws, but it's not so obvious at the first sight how to do it. But look, here we have the law which says that number 1 can be replaced by the logarithm. So in this case, our base is 2, and therefore the number 1 could be replaced as the logarithm in base 2 of 2 itself. So let me do that. It's the logarithm in base 2 of 5 minus, and we have logarithm in base 2 of number 2. This replaces number 1. This logarithm here replaces 1. Now, again, since there is the difference in two logarithms, so there is a subtraction used here. What we use is this law here. So this should be the logarithm in base 2 of 5 over 2. And it can be replaced like this. It's the logarithm in base 2 of 2.5. So this should answer the last part of this exercise. Now, there is a way for us to see it in a little bit different way, and it is as follows. You may imagine this number 1 as the result of the following, as the logarithm in base a of a to the power of 1. There is the first power there. So this, according to the third law of logarithms, which says that the logarithm in base a of x to the power of y is y times logarithm in base a of x. According to this law, this should be nothing else than 1 times, so this is your y, 1 times logarithm in base a of a. Okay, so since logarithm in base a of a is 1, we have just 1. Okay, now why do I mention this? Imagine that instead of 1 there would be number 2. Okay, if there was 2, how to replace number 2 using logarithms? And this is how. It's the logarithm in base a of a to the power of 2. Okay, why? Because using this third law of logarithms, we have it's 2 times logarithm in base a of a, which itself, this is 1, so it must be 2. This may be useful in later exercises.